Today we're going to work with solving trigonometric equations. So this will be our first day of this. We've worked with sine and cosine, tangent, and the unit circle, inverse sine, cosine, and the unit circle. And we're going to apply those skills today for something new. So sometimes we'll have to find an angle from an equation, and that's where we're going to start at today. So some of them will be with the unit circle, some of them won't be. In this case, we're doing all the solutions on the interval from 0 to 2 pi, so that's all the way around the unit circle, and then we stop. So if we keep going, we'll have more solutions, but in this case, we're just between 0 and 2 pi. So over here, I've got 2 times the sine of theta equals negative square root of 2, and just like any other algebraic equation, we can divide both sides by 2 to get that sine of theta by itself. So we want the sine of theta to be equal to the negative square root of 2 over 2. In essence, all we're doing is taking the inverse sine of both sides. And a lot of times I'll skip right in the step down, so I don't want to confuse you if I forget to write that down, but sometimes I'll skip that and we'll just go to theta. So we need to find values on our unit circle where the sine is equal to negative square root of 2 over 2. In this case, there's one down here at 7 pi over 4. And there's another one. Negative square root of 2 over 2 happens at, I wrote that first one down backwards. It's 5 pi over 4 and 7 pi over 4. Alright. So in the next few examples, the next example will be just about the same thing. We've got an equation. We're going between 0 and 2 pi. Then we got 2 cosine theta equals 1. So we divide both sides by 2. And we're left with cosine theta equals 1/2. So again, I can leave it like this. I can do the inverse cosine. I can write that down. I'm just going to write theta equals, and then I'm going to find where the cosine is equal to 1/2 on my unit circle, and that's pi over 3. And I've got another value where the cosine's 1/2. It's down here at 5 pi over 3. Alright, so that gave me an interval. I'm only doing those two numbers. What happens if I don't just have that interval? What if I say find all solutions? So what all solutions means is we go around the circle once, we can go around twice, we can keep going around the circle. Alright, so we're not just limited between numbers between 0 and 2 pi. We're going to start with the numbers between 0 and 2 pi first though. So we're going to start just like we did before. We're going to divide both sides by 2. And we got square root of 2 over 2. So where does that equal square root of 2 over 2? Well, the first one is pi over 4. Now if I go around the circle again, I go around a total of 2 pi. So I'm going to add on this. Now 2k pi. The k is an integer. Alright. So if I put in 5, that means I go around the circle 5 times. If I put in -1, I go around the circle backwards. That's not my only one though, because I've also got this 7 pi over 4 that has that square root of 2 over 2. So I've got 7 pi over 4, and then again I've got 2k pi, because I can go around the circle multiple times. That's why the 2k pi is there. So if it says all solutions, you need the 2k pi. The rest of it works out the exact same way though. Alright, so all solutions. First step, divide everything by 2 on both sides. I'm looking for the sine of theta being -1/2. Alright, so -1/2 occurs at 2 places on the unit circle. Alright, so at those 2 places, I'm going to have theta equal to 7 pi over 6. And then I've still got to add that 2k pi on. And theta is equal to 11 pi over 6 plus 2k pi. So again, k is the number of times you go around the circle. So if I go around once, I'm here. If I go around, so that's 1. If I go around twice, that's k equals 2. And I keep going around however many times we need to, I still get to that same value. So I found all solutions where 2 sine of theta equals -1. Alright, this one works very similarly, but it is a little different because we've got that 3 inside with the theta. So first step, same as before, divide by 2. So I'm left with sine of 3 theta equals 1/2. Now, we don't have 3 theta on our unit circle, so I'm going to change 3 theta into a u, and I'm going to do the sine of u equals 1/2. What this will allow me to do is look at my unit circle and figure out what u is. So I've got 2 values of u on this unit circle where the sine is equal to 1/2. I've got pi over 6, and since it says all solutions, I need my 2k pi again, and I've got 5 pi over 6 that I'm adding my 2k pi onto. Now, I'm not all the way finished because I have to take and replace this u with 3 theta. So I'm going to replace 3 theta for that u, and then now I just have to divide everything over on the right hand side by 3 to find theta. So my final answer for theta is equal to pi over 6 divided by 3 would be pi over 18, and then my 2k pi becomes 2k pi over 3, and my second one does the same thing. It's 5 pi over 18 plus 2k pi over 3. Alright, so I had to substitute so I could figure it out, and then I plug it back in. So here it says find all solutions again. So here I don't have to do anything. I've got cosine pi over 4 theta equals -1. I don't have anything to change first. I just go with this. I do need to change that pi over 4 into another variable just to replace it and make this cosine of some number equals -1. Alright. If we go to our unit circle, there's only one spot where the cosine is equal to -1. So that means u is equal to pi plus however many times we go around the circle, 2k pi. And then I substitute that pi over 4 theta back in. And pretty much in order to divide by this, I multiply both sides by the reciprocal of 4 pi. Over pi. I said 4 pi, I'm sorry. So that means theta equals 4 over pi times pi plus 2k pi times 4 over pi. So that means my first part, the pi's cancel out and I'm left with 4. The second part, the pi's cancel out again and I'm left with 2 times 4, which is 8 k's. So theta would equal 4 plus 8 times whatever integer value for k. So k is an integer, however many times we go around the circle. Sometimes we'll be asked to find some things, solutions between 0 and 2 pi, and it's not on our unit circle. So this is straightforward. I don't have to solve anything else to find what the sine of x equals, because I'm told the sine of x equals the 0.27. So I just need to do x equals the sine inverse of 0.27. Now if you type that into your calculator, we've been doing radians here, so make sure you're in radian mode. X will equal 0.2734 radians approximately. Now, we did some of these before where we had to find the same sine value, and I hope you realize that if I have 0.2734 radians over here, I've got another angle that's the exact same distance from pi that I need, that will have the same sine value. So I need to take pi minus that 0.2734 to find my other angle. And if you do that, you get your other answer for x being 2.8682. So we're going to have two values of x that work. And then, similar situation, but it says to find the first two positive solutions. So to get started, we need to get sine of 6x by itself by dividing both sides by 7. So the sine of 6x equals 2/7. Now, I don't like that 6x there, so we need to change it. So we're going to change it to sine of u equals 2/7. Once we do that, we can do the inverse sine of 2 divided by 7. That means u, which equals 6x, equals 0.28975. So once we do that, we can figure out x really easily. One of them will be 0.2875 divided by 6, which is 0.04829. The second one's a little trickier because we've got to remember our u value is somewhere over here, and I need my other u value to be pi away, that number subtracted from pi. So my other value for u, my other value that 6x equals to, is pi minus 0.28975. Alright, so my other value is over here. So I need to take and divide both of these by 6, or I subtract them and then divide by 6. However you do it, you get another value of x. Alright, so I'm not going to take pi minus this x value. I'm going to take pi divided by 6 minus that x value. And or I can do this subtraction first and then divide. I don't care how you do it. You should get the same answer as what I just wrote down. So the key to the problems that we're doing today is to follow the steps. Use your brain. Use the skills we've developed and talked about so far with our unit circle and angles with the same sine value and cosine values, and you should not have a problem with most of these problems.